Hello everyone, welcome to another session on teaching you guys about smart contracts. In this session, we'll be exploring the key topics of inheritance and interfaces in the Solidity programming language, including their benefits, definitions, and practical examples. Introduction to inheritance in Solidity. Inheritance allows one contract to inherit the properties and methods of another contract. This promotes code reuse and organization. This section will cover how to define inheritance in Solidity contracts, including the syntax. In Solidity, you define inheritance using the is keyword. A derived contract inherits all state variables and functions of the base contract. Defining inheritance is like creating a new recipe that builds on an existing recipe, adding or modifying ingredients as needed. For example, consider the following code. Here we have two contracts, the base contract and the derived contract, where we have used derived contract is base contract, that is, the derived contract is based upon the base contract. In the base contract, we have initialized it with a constructor that has an input as a name. In the derived contract, we have a constructor initialized with name as well as age. Moving on, inheritance helps you structure a Solidity code in a logical manner, making it easier to understand and maintain. By inheriting from parent contracts, you can easily update or modify shared functionality without having to change it in multiple places. Introduction to interfaces in Solidity. So what exactly are interfaces? Interfaces in Solidity are defined using the interface keyword. They can include function declarations without implementations. Contracts that implement the interface must provide the function definitions. Defining interfaces like writing a job description, and implementing interfaces is like performing the task outlined in that job description. Interfaces define the functions that a contract must implement without providing the function implementation. They ensure that different contracts can communicate with each other. Interfaces are like a job description that outlines the responsibilities but does not detail how the task should be performed. Contracts that implement an interface must provide the function implementations as defined in the interface. We'll see an example of it later on. Benefits of interfaces in Solidity. Benefits of using interfaces include ensuring compatibility between different contracts, promoting modularity, and enabling contract interaction. For example, if you have contract 1 that is based upon the interface of contract 2, then the contract 1 must include all the functions that are mentioned in the contract 2 so that it can be compatible with the contract 2. Interfaces are like having standardized job descriptions that ensure everyone understands their roles and can work together effectively. In the coming slides, we have provided a code example that demonstrates the use of inheritance and interfaces in Solidity. It includes a base contract vehicle that defines common properties and functions, a derived contract car that inherited its properties from vehicle, and an interface insurance that is implemented by insured car contract. Vehicle contract defines two public properties, speed and color, along with corresponding setter functions. The car contract inherits from vehicle and adds a new property model along with a setter function. The insurance interface defines two functions, set insurance details and get insurance details, which are used to set and retrieve insurance related info. The insured car contract inherits from both car and insurance and implementing the required interface functions and adding insurance specific properties and logic. So here's the example. First of all, we have specified the Pragma Solidity version and we have written the base contract, that is contract vehicle, which has two variables of type input and string. Both are public and the name of both are speed and color respectively. First of all, we have a function setSpeed which takes an input of type uint with the name speed. This is a public function and it sets the speed variable its value. Next, we have a function setColor which takes an input of the color string, which is a public function, and stores the value of color in the variable color. In the derived contract, that is contract car is vehicle, we have a string public model, that is a variable which stores the model of the car. This is a public variable. In the function setModel, we take an input of the type string, which is the name of the model, and we store this model value in the model variable. So with this, we learned that in the derived contract we added one more value apart from those two values already included in the base contract. Moving on to the part of interface. First of all, we have an interface called insurance which has two functions, set insurance details and get insurance details. Both are external functions. Now you can see that we have made our contract insured car using the interface of car and insurance contracts. So we have to include those two functions that are described in the insurance contract, that is set insurance details and get insurance details. And we also provide an override keyword to tell that this function are already included in the insurance keyword and we are describing it on our own. Recap of key points. Inheritance allows for code reuse and organization by enabling derived contracts to inherit properties and methods from base contracts. Interfaces ensure that different contracts can communicate with each other by defining a set of functions that must be implemented. Abstract contracts provide a base with both implemented and unimplemented functions, serving as a template for both derived contracts. With this, I conclude this session. Thank you all for joining in. Hope you have a great day.